part two to the revision slides, we're just going to be covering 4F onwards. Now, depending on how long this will take, it may potentially be split up into three parts in total, but we'll just see how it goes, okay? So first off, we're just going to talk about the gradient intercept method, okay? So all you're going to do is make your equation turn into the general form y equals mx plus c here. Now you need to identify what m equals to and what c equals to, okay? So make sure you do that. So let's just go through an example right now. So I have some equations here already set up. Now let's just identify what m equals to in the first one, y equals to x plus 1. So just remember we have y equals mx plus c, and m is just a number in front of the letter x. So as we can see here, m equals to 2. Great. And then for c here, we have positive 1. For the second one, y equals negative 4x minus 2. So we have here m equals to negative 4. Now, a lot of people will say c equals to 2, but this is wrong, okay? Don't just write that. What c actually equals to is negative 2. And this is the correct answer right here, okay? Because it's minus 2 that you're looking at, and our general equation was plus c. So because it's a minus there, you just write negative 2, okay? Now for the final one, it's a bit tricky because we can tell what m equals to. That's pretty easy. That's pretty straightforward. But you ask yourself, what does c equals to? Now, there's no c value. Since there's no c value in our equation, you're just going to write c equals to 0, just like that. Pretty easy, yeah? Okay, transposing equations. Now, this is a skill a lot of you will need to learn for next year. So let's just start on it now. Now, it's a bit weird at first, but I think after the more you do it, the better you will be at this, okay? So let's just get to it. So, your equations will initially look weird, but it's your job to make the equation look like y equals mx plus c. Now, what you're going to do is apply your inverse operation skills, okay? So let's just get started. So I'll just write up here, this is what we want here, y equals mx plus c. That's what we want. That's the goal. So let's just work through this. X plus y equals to 4. Now I want it to look like y equals mx plus c. So just compare it, okay? Now what do I need to remove to sort of make it look like that equation right there? So I'm first going to target this x right here. Going to target that, get rid of it, okay? So the inverse operation skill I'm going to apply is minus x. Because if you remember right here, when you don't see a sign right there, that typically means plus, okay? So it's a positive number. So that's why the inverse operation we apply is minus. So when we do that, it becomes x plus y minus x equals to 4 minus x, just like that. Now, what actually happens is the x will disappear from the left hand side completely because that turns into 0. So all I'm left over with on the left hand side is y. And then I have here 4 minus x on the right hand side. Now, because we're trying to achieve this mx plus c here, I can see that this is a bit weird. So what we're going to do is we're going to switch them. Switch positions. So when that happens, okay, you have to be very careful. So you see this minus sign here, that's actually a part of the x right there. And then for positive 4 here, we have something different. So we're just going to switch those two around. So when that happens, I end up with y equals to negative x plus 4. Now, the reason why it's plus 4, because over here, if you have a look, that's a plus sign right there. It's an invisible plus sign. So that's why we add plus 4. And now it looks like the equation we want. So great, we're done with that. Okay, so this is done. Let's move on to the second example here. 2x minus 3y equals to 6. So let's just apply the same skills as earlier. Let's just get rid of the inverse operation, okay, of minus 2x. So when that happens, I get 2x minus 3y minus 2x equals to 6 minus 2x like so. Now when that happens, on the left hand side, the 2x disappears. So what I'm left with on the left hand side is negative 3y. And then I have 6 minus 2x right here. Now we're just going to do the same thing. Let's just switch positions between the c and the mx values. So this now becomes, so switch. We end up getting negative 3y equals to negative 2x plus 6. And then let's just have a look here. We want y equals, not negative 3y equals 2. So what we're going to do now is divide both sides by negative 3. So when that happens, you're going to apply negative 3 to each term. On the left-hand side, the negatives and the 3 will cancel out. And you're only left with y on the left-hand side. And then you have here negative 2 divided by negative 3. That just becomes positive 2/3. And then just attach the x there. And then you have 6 divided by negative 3, which ends up being negative 2. So I have y equals 2 over 3x minus 2. So this is really important, okay? You need to learn how to do this for next year onwards. But the more you do it, the more you will get used to it, okay? So I don't expect you to pick up this skill now, but if you do pick it up, that's great, okay? All right. Next one we're doing is finding the equation of a line. Now there's 3 different variations, okay? So you need to know how to do this. The first one is when you are given the graph, okay? So step 1 is always write y equals mx plus c. So just write that to start it off, okay? So just write this somewhere. Step 2 is look at your graph, determine your y-intercept. So just have a look at the graph that you're given. Just find where the y-intercept is. So we can see that the y-intercept is at negative 4. So y-intercept is at negative 4. What this means is the c value is going to be negative 4, just like that. Now step 3 mentions to use m equals rise over run to determine the gradient. So let's just draw ourselves some triangles. Let's just determine the rise and the run. So the run's going to be 2, the rise is going to be 4. Okay, so with that in mind, let's substitute the values in. M equals 2, 4 over 2. But let's just pause for a moment. Okay, look at the graph. Like, it's going downwards, yeah? Since the slope's going down, that means it's actually a negative gradient. So make sure you include the gradient in there. So this now becomes m equals to negative 2. And then the final step is to just put it back into the equation. So your final answer will be y equals to negative 2x minus 4, just like that. Okay, so that's the first method. The second method is when you are given the gradient and you're just given a coordinate point of the line. Okay, so let's have a look here. So I have a gradient m of 1/3 and we have the point 92. So let's just start out by following our order, just writing the equation. Step 2, say substitute m into my formula. Since I know m equals to 1 over 3, I can just substitute it in. just like so. Step 3 here says substitute the coordinate points. So since we're given the coordinate points 9 and 2, I am just going to substitute that. And that's what it should look like so far. Step 4 says solve for C. So as you can see here, the only variable I have left available is C. So that's what I'm going to solve for. So I'm just going to write down the last thing I wrote from step 3. And now I'm just going to solve it. Now 1/3 multiplied by 9 is just 3. Let's see. Now if you don't know how this works, it just becomes like this. Now another way of writing the whole number is just putting the number and then in the numerator and the number 1 in the denominator. And when you multiply by fractions, typically you always multiply across, right? So it becomes 9 over 3. And then 9 over 3 is the same thing as 3. So that's how this becomes that one right there. Okay. And now you just solve by applying the inverse operations. So I'm just going to write 2 equals 3 plus c. Going to subtract by 3 on both sides. So I end up with 2 minus 3 equals 3 plus c minus 3, just like so. Now the 3's cancel out in the right hand side. So now I'm left with -1 equals to c. So since I know what my c value is, and we're already given my m value, I can just substitute it into my equation. So 1 over 3x minus 1. And that's my equation right there. That's the second method, okay? Now, we are going to find the equation of a straight line, but we're given 2 coordinate points, okay? So I'll just highlight some points, given gradient and a point there. And this one's just when you're given the graph, okay? So, say for example, they give you 2 coordinate points like this. You are now going to use this other formula to help you determine the gradient, okay? Very important right there. So make sure you have it in your summary sheet. So let's just figure it out, okay? So step 1, y equals mx plus c. And now find m using the formula. Just like that. Actually, I'll write it up towards the top. It'll be neater. Now, step 3 here says substitute m into your formula, okay? So let's just do that over here since I didn't give myself enough space. I don't know why. All right, so let's just figure it out, okay? So this equals to, I gotta write this again. How would I write this? X1, X2, and then you have Y1, Y2. And I'm just gonna put stuff in between to fill it out, just to make sure it makes sense. So since I know y2 is 9, I'm just going to substitute it. Minus 5 over 3 minus 1. So if I simplify it, I get 3 over 2. And 4 over 2 is the same thing as 2. So that means m equals to 2. So that's step 2 done. So, so step 3 says substitute m into your formula. Okay, let's have a look here. Y equals to 2x plus c. Now, step 4 says substitute one of your coordinate points given. You can choose any. So, if you have a look at our question, we're given 2 coordinate points. Just pick one, okay? I don't care which one you pick, as long as you pick the one consistent one, okay? Just for simplicity's sakes, I'm going to pick the easiest one, which is the coordinate 1 and 5. So, I'm just going to choose 1 and 5, okay? So, I'm going to substitute this now. So, it'll look like this. And now we're just going to solve for C. So let's just solve for C real quick. And the 2's cancel out on the right hand side. So I end up with c equals to 3. And then the final step is put it back into the equation, y equals mx plus c. So we know we're given this, y equals 2x plus 3. And that's your formula right there, okay? So that's how you'd go about finding the equation of a line using 3 different methods, okay? Chapter 4H, midpoint and length of a line segment, okay? So what's a line segment? So it's just a straight line that has 2 fixed endpoints, okay? So if you have a look there, I've drawn 2 endpoints and the line between them is what we call the line segment, okay? So that's all it is. Now, the first skill you need to learn is finding the midpoint. So the midpoint is pretty much the halfway point between the line segments. So if you have a look at the line here, I'm just sort of pretty much finding what's the middle coordinate point that somewhere lies around here or something, you know? So we're trying to find that coordinate point specifically. Now, to do that is very easy. You are just finding the average position of the 2x values and the 2y values, okay? Now, there's a formula that we use. This is the formula that we use right here. So capital M equals to x1 plus x2 over 2, and that's for the x coordinate. And then you have y1 plus y2 over 2, which is the y coordinate, okay? And it's pretty easy to apply. Let's just get to it. So I'm going to start out by writing the formula. And now you're just going to substitute, okay? So this now becomes x1 is the number 1 plus 4 divided by 2. And then I have 0 plus 4 divided by 2. And then you just simplify the fractions, okay? So I end up with 5 over 2. And then this becomes 2 like that. Because when you do 0 plus 4, that becomes 4. And 4 over 2 is the same thing as 2. Now, if you don't know where the fraction is, like on the axis, you can convert to decimals to sort of give you a good idea, okay? So another way of writing 5 over 2 is actually 2.5. So that means the coordinate, the midpoint, is actually at 2.5, at the coordinate point 2.5 to 2. And if you really wanted to draw a line, you could sort of see it, okay? Now we'll do the other one real quick. Always start out by writing your formula, because that way I know what your intentions are, okay? And then all you have to do is just substitute the values afterwards. So I'll just do that real quick. Negative 3 plus 5 over 2. And then I have here negative 2 plus 3 over 2. And I'm just going to figure it out. It becomes 1 and 1/2. Now, if you're wondering how I got this, negative 3 plus 5 is positive 2. And positive 2 over 2 is just turns into 1. Negative 2 plus 3 is 1. And 1 over 2 is just 1/2, okay? And if you really wanted to write it as a decimal form, 1 and 0.5, okay? So that's where the midpoint is. Now, the next thing you're going to learn is length of a line segment. So what you're doing is you're trying to find how long the red line is, okay? You're finding how long that is exactly. Now, I have an example set up already, but here's how you're going to do it, okay? You must understand that this will apply Pythagoras theorem. So we're going to actually use the Pythagoras theorem to help us find the length of this line right here. And there's a specific way to do it, okay? Now, just to get the whole understanding around it, you need to create a right angle triangle. which is what I've set up already, and I've labeled it as C, A, and B. Okay. Now, A in this case is going to be the difference in the x values, aka the horizontal length, and B is going to be the difference in the y values, which is the vertical length. So, this is the main formula you will use right here, just for simplicity's sakes. And let's just go ahead and do it right now. So let's find the change in the x values. So let's have a look here. I have -3 and I have -1 here. So just talk to yourself and be like, all right, what's the change there? And you can sort of figure it out that it's actually just 2. And then for the vertical value, the vertical change, I have here 5 and I have here 2. So what's the change between 5 and 2? So it's going to be 3. Now with that out of the way, I can actually just do this right now. I can just substitute those values into my equation, okay? So this will be length equals to change in x plus change in y. And since we figured out what the change in x and y are, so let's have a look here. Change in x is 2, change in y is 3. So I'm going to write 2 squared plus 3 squared like that. Now, when you square this, 2 squared becomes 4, 3 squared is 9, and you just add it up to be 13 units. And this is your final answer, okay? Just like that. It's pretty straightforward, yeah? Uh, Now let's just get rid of that. I'll just redo this one right here, but I'll just do the simpler way, okay? Just like this. So you just have a look at the graph here, um, look at the corner points, find what the difference is, but I'm just filling this in. Change in x squared plus change in y, just like that. So we found the change in x to be 7, so 7 squared plus the change in y, which is 11 squared, and we're going to put that underneath the square root, and then you just sort of figure it out, okay? Just like that. And then when you add it up, you get 170, just like that, okay? There we go. That's your final answer, okay? So when you're given a graph like this, you can sort of figure it out pretty easily. Next thing is parallel perpendicular lines. It's chapter 4I right here. So just remember parallel lines, okay? If they are parallel, they have the same gradient, okay? So that means the same m value. And if you have a look at my graph here, y equals 2x plus 1 as the red line, y equals 2x minus 2 as the blue line, the gradient value is the same. Let's just go over this real quick. Decide if the pairs of lines with these equations are parallel, so they have the same gradient. So I'm just going to highlight the m values for each of them, and then just tell me if they're parallel or not, okay? So in the first one, I have here m equals to 3 on both of them. That means it's true. In the second one, I have m equals 7 and m equals to 2, which is not parallel. And in the third one, you have to be very careful. I have m equals 1 half and m equals negative 1 half. These are not the same, okay? Not the same. Therefore, it's false, okay? It's not true, okay? They're not parallel. Perpendicular lines. So perpendicular lines are when you draw two lines and they intersect at some point, they create a 90-degree angle, okay? Now, there's a formula that we use to help us, m1 times m2 equals negative 1. But your main concern is using this bottom one here, where m2 equals to negative 1 over m1. Now, just remember, okay, this is what the m1 and m2 means. m1 is the gradient of the line you're given. m2 is the gradient of the perpendicular line, okay? So let's just have a look real quick over here. If m1 equals to 4, then m2 equals to something. So let's just write out our equation. m2 equals to negative 1 over m1. And you're just going to substitute m1, okay? So that means m2 equals to negative 1 over 4. And this is the gradient of perpendicular, okay? That's all it is. Now let's do the same thing as before for the next example. So m2 equals to negative 1 over m1. We're going to substitute. Now this is where it gets a bit tricky. Negative 1 over negative 2 over 3. Now, this over here is actually a dividing sign here. That fraction right there is a division sign. So what you're going to write is negative 1 divided by negative 2 over 3. And then you apply KCF. Change flip, if you remember. So if we do that, it becomes like this. And then it actually ends up being positive 3 over 2. Okay? So that's what M2 equals to. Okay? Just like that. Linear modeling is just worded problems. You just got to read the question, okay, and then just answer accordingly. I probably won't cover this one. You have it all there already. And then we'll just cover this one, graphical solutions to simultaneous equations, okay? This one is the most recent one, so I'm pretty sure we won't need to talk about it as much, but just remember two scenarios you can have: intersection at one coordinate point, or you could have no intersection, okay? And whenever you have no intersection, that's when the two lines are parallel, okay? An example of this would be, just look at the graph, just pinpoint it, and just tell me the coordinate, just like so, okay? Negative 1 to positive 2, just like that. I'll probably stop here. I'll probably talk about these methods again. Um, I'll just talk about it again just to make sure, okay? So I'm just going to take a break real quick. But yeah, this is part 2 of the revision sites on chapter 4 for linear relationships. Please make sure you study hard. If you have any questions, please ask me. You have 2 revision lessons to ask me to help you, okay? All right, study hard. Toodaloos.